Hello, this is Danica,
And Jordan.
and we are here to record homework 10 for our Engineering 460 Monte Carlo class. So the problem statement for this homework is from our book, and the book problem says, generate by hand the complete cycle for the linear recurrences A to F below. State the observed period and verify that it is in agreement with theory. So you can see these here. The biggest difference for these is just like the initial x, and then obviously part C has 7x here instead of the 5. And then this problem statement says go from parts A through F below, but then in the problem statement given by our professor, we just need to go through A, B, and C. So, and then for each one of those, he wants to see a handful of results of the random numbers generated by Matlab, and then at the end, we're going to display a graph of random numbers where A is being plotted for the x-axis and B for the y-axis.
Okay, so moving on to our first one, this is part A. So basically we have the A starting off as 5, and we have the mod function where it is right here, and the random number generated is just the x divided by the modulus, which is 16, which can be shown here. And then what we did here is we just showed the first 10 randomly generated variables. So here it is in Matlab. We can see that there's a period of 16, and we can see that the answer, these are just 10 randomly generated numbers from this function. Moving on to the second one, it's the exact same mod function, except the initial is 7 instead of 5. So we see that it has the same period since it is the same mod function, and we have 10 variables generated. And as for the third one, we see something interesting. We notice that there is a period of 4, and since there's a period of 4, we should see that it repeats. And after 4, guess what? It repeats. So it is true that this has a period of 4. So moving on to our actual graph. Now, because A and B are both the same modulus and both the same linear congruential generator, just with different initial x's, we expect to see these lines generated. These lines generated demonstrate the complete period of the function. Now, the reason why we only did it for the 15 or 16 points demonstrated here is that if we went past that, it would repeat and just put another one at one of these points where it started off. This is typical of seeing modulus generators. This typically is the pattern shown by having different starting points. And with that, we are done.